Hello everyone, my name is Shalom, and today I'll be doing 2005 Step 1 Question 3. So let's just get into it. So in the first part, A and B are distinct non-zero real numbers and C is a real number. I need to show that if A and B are both positive or both negative, then the equation written here has two distinct real solutions. Okay, so let me draw out the equation. X over x minus a plus x over x minus b equals 1. Now my first instinct is to multiply on both sides by x minus a, x minus b. So this would become x. This implies that x minus b plus x minus a equals 1. Equals x minus a, x minus b. And then I expanded on both sides. So x squared minus bx plus x squared minus ax equals x squared minus ax minus bx plus ab. And on both sides, we have x squared on both sides, we have minus ax on both sides, we have minus bx on both sides, and we can cancel those out. And therefore, x squared equals ab. X squared equals ab, and we can take the square root of both sides. So x equals the positive root or negative root of root ab, and this only has, x only has real solutions if both a and b are positive or negative, as those imply ab greater than 0. Yeah, it only has two positive real solutions that are distinct if both a and b are greater than 0, because if they were equal to 0, then this would only have one distinct solution. But if they both have to be positive or both negative. Now let's move on to the next part, II. So show that if c is not equal to 1, then this equation has only one real solution if c squared equals minus 4ab over a minus b squared. So again, with this equation, let's write out first. So we have this equation, and we want to make it into a more obvious quadratic, so we can hopefully go somewhere with that. So let's multiply by x minus a, x minus b on both sides. And then let's expand. So at first I want to expand the right hand side using a grid. It makes it easier. So this is bear with me. Okay, so that means that the equation becomes x squared minus bx plus x squared minus ax equals 1 plus c x squared, and then minus a plus b plus ac plus bc x plus ab plus abc. I'm just making all the coefficients of x, I'm factorizing them to make it like easier to see as like a quadratic. And then there's an x squared on this side and an x squared on this side, so we can cancel that. And then there's a ax on this side, ax on this side, ax on this side, and ab on this side, and bx on this side, bx on this side. So we can cancel all of that as well. So now we have x squared equals cx squared. X squared equals cx squared minus plus ab plus abc. And then we can take away on both sides. So let's take away x squared on both sides. So now we have 1 x squared ac plus bc x plus ab plus abc. Now one thing to notice is that if c, the reason c is not equal to 1, if c equals 1, then we can't recover a quadratic, so this no longer becomes a quadratic. So let's move on. So now we have this in the form of a quadratic that equals 0. So let's take the discriminant, because we're trying to see, we're trying to show that if the condition, this condition here means that it only has one real solution. So if it only has one real solution, then that means that means there's a repeated solution. So, and the discriminant here is b squared minus 4ac, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant value. So the discriminant would be minus ac plus bc squared minus 4a c, and that equals to 0. Now let's expand this. So this equals c squared a b squared minus, we can expand this somehow. Let me minus 4 abc plus abc squared minus ab minus abc, and the two abc minus abc cancel out, so we're left with minus 4 abc squared minus ab, and that all that equals 0. So now what we can do is, I want to collect these. So I want to take c squared a plus b squared minus 4ab. Let me first expand this out. Minus 4ab equals 0. And I want to factorize out c squared from that. So c squared a minus b squared minus 4ab minus 4ab equals 0. And now I want to expand the inside of the bracket. So it's a squared plus 2ab plus b squared minus 4ab and this becomes c squared b squared minus 2ab plus b squared equals 0. Shit, that's plus. That is a plus. Because there's a double negative here and here. And then this is the expansion of a minus b squared. So c squared plus 4ab equals 0. And now I want to move the 4ab to the other side. So we take it away on the side. And now divide by a minus b squared. So that equals minus 4ab over a minus b squared. And now we have finished the second part. So we have shown that it only has one real solution if this condition holds true. And it does, in fact. So now we have to show that this condition can be written as this. So the first thing I notice is that there's a 1 here, but this denominator is still the same. So we can use some algebraic manipulation and we can add and minus the same thing to get the same top and bottom. So we know that a minus b squared is a squared minus 2ab plus b squared, and then that is all over a minus b squared. And then we have to take those away now. So minus a squared, and then minus 2ab minus b squared. And if we collected all of this, we would get minus 4ab. So we haven't actually changed anything because we're adding and subtracting by the same number. But now we can divide up the fraction into two fractions. So we can get a squared minus 2ab b squared over a minus b squared. And then minus a squared plus 2ab plus b squared over a minus b squared. And then we know that this is equal to a minus b squared. So that's just a minus b squared over a minus b squared. My pen's bugging. What is going on? That's just a minus b squared over a minus b squared, which is 1. And then this is a squared plus 2ab plus b squared is just a plus b squared. That's over a minus b squared. So this equals 1 minus a plus b over a minus b squared. And we have shown that condition can also be written like that. And now for the last part, deduce that it can also only hold if this inequality is true. So well, it can only hold. Deduce means that we don't need to do that much more to get to that solution. So let's look at both sides of the inequality. First, let's show that c squared has to be greater than 0. Well, if we recall from the previous part that c squared equals minus 4ab over a minus b squared, and we know that a is not equal to 0, and we know that b is not equal to 0, so therefore c squared cannot be equal to 0. Okay, and also we know that c squared, as c squared is a square number, it has to be greater than equal to 0 for c in a sense, for c being a real number. So if c is greater than or equal to 0 and c is not equal to 0, then therefore c is strictly greater than 0. And now to prove that c is less than 1, well, we can go back to our previous part that we just proved. We'll call that c squared is equal to 1 minus a plus b over a minus b squared. Well, because a and b are both real numbers, then a plus b over a minus b squared is also positive. It's positive, right? But we've proven that c squared is greater than 0. So it can only be greater than 0. So this c squared can't be negative. This can't take us into negatives. But also it can't be greater than 1 because as this is always positive, so 1 minus that is always greater than 1. I mean, it's always less than 1. So b squared is less than 1. So, or equal to if a equals minus b. So we've proven that 0 is less than c squared is less than or equal to 1. And that is the question. Thank you for watching.